food we have. Because the feed they are giving for a goat or a hen or which we take, which we ingest, has also antibiotics in it for making them free from microorganisms. So nowadays people are so aware, and they woke up because we can see a lot of advertisements by some of the food companies that this is antibiotic free food. Antibiotic free chicken, or it is an organic thing which doesn't have any pesticide or any antimicrobial agent. So they are advertising in that way, so that the whole world has waken up for this particular thing, because every individual, even some layman has awareness of these kind of antibiotics. So don't take antibiotic as such. It will the organisms, everybody has a knowledge of this particular thing. So the FDA has been working on this. So usage of drugs, the usage of drugs has been usage of drugs and the usage of some contents as a pesticide, even as a pesticide. They are working on it. They have removed the list of things which are doing these kind of harmful to our DNA. They are already have been removed by FDA in food. Food for animals and all. So again, this is the drug resistance in bacteria. These are some reports of drug resistant bacteria. So as we say here, Escherichia coli, Klebsiella pneumonia, these already have antimicrobial resistance, which has been now GLAS is working on some part of it to get antibiotic, new format of antibiotics which could work. So it is an alarming situation that people should be aware of antibiotics and the dosage of antibiotics what we are using. Again, you can see here Klebsiella pneumoniae, which is a common intestinal bacteria, again which causes a life-threatening infections. So you can see here infants get affected in even newborns, and patients who are already been weak in their immunity can easily catch up with the disease, and already they have been introduced into many antibiotics for patients who are suffering from a lot of infection. They are already been exposed to lot of antibiotics. So the organisms get used to the antibiotic, and they prepare themselves to grow against these kind of antibiotics. So again, these are some examples we are seeing here for antibiotic resistance bacteria. So again, this is also the continuation of the same thing. As we said, we have Staphylococcus aureus, which I have mentioned earlier, and Staph aureus is a major threat in post-operative care, and still we are facing the same problem. And Staph aureus has already escaped a lot of antibiotics, and now it is MRSA, which is a serious concern for post-operative care. And Neisseria gonorrhoeae, sexually transmitted disease, again has a wide spectrum. Antibiotic doesn't work on this particular organism, and it has been again a serious threat. So as we say, Mycobacterium tuberculosis. WHO has working on law and has put in a lot of effort and fund for this Mycobacterium tuberculosis, and again it regenerates with this special capacity to overcome all the antibiotics and drugs they use for their treatment. And again, these are some drug resistance in viruses. As we have seen in a live status that for 2 years we are working on a particular virus, and and a small particle or small microorganisms kept us stake for more than 2 years, and we are recovering from that particular phase, and still we don't know whether this vaccinate will work, or this guy will again get mutated again. For the drug what we use or the vaccination what we use, we don't know what going to happen. So it's still a complicated one. This particular drug resistant microbes, I could say drug is not a drug resistant virus. Drug resistant microbes is a very threatful one, and some of the WHO reports even say that the sewage water, which carries all the organisms, are having a capacity of drug resistance for many important drugs which we use nowadays. Because in sewage we already have a lot of chemicals, antibiotics, everything will be there, and the organisms thrive to grow in that particular one. And it is stated that in a research article that we have a wide variety of antibiotic resistant microorganisms found in sewage water. So again, it's a serious threat, and here we can see HIV, which has a drug-resistant capacity, and as we know, we are now facing the same crisis for this coronavirus. And again, even parasites, malaria parasites, they have this similar. They have crossed, and their approach actually, as a lot of countries have already been into this, and they are looking seriously into. They have already removed some pesticides, some antibiotic compounds, and some harsh chemicals, both in food and also in the agricultural practices. They have removed, but still India has not got hold of these particular areas, which is really a dreadful thing, because the plant absorbs all the good or bad minerals, heavy metals, or whatever it is. They observe everything from the root, and they put it in the fruits or flowers or whatever they have in the storage area. When we inhale or when we ingest those kind of I would say it is also an infected thing. We will acquire a lot of complications. Like again, we'll have some cancer causing oncogenic properties will be there. So a lot of things we are facing. Even in agriculture, it affects the microbes which is present in the in our body, animals, in animals, in plants, or in a root and rhizosphere, whatever they get affected, and directly it affects our body. So medicines, vaccines, and diagnostic tools, especially those targeting and critical gram-negative bacteria such as carbapenem resistant Enterobacteriaceae and Acinetobacter baumannii. These are these new antimicrobial medicines has to be concentrated more for research purposes. So we have a WAAW, was previously it is called as World Antibiotic Awareness Week. From 2020, it is called as antimicrobial. So antimicrobial, as we say it as antiviral, antifungal, or antiparasitous, and we have everything. So the scope, it has been broadened. The antibiotic has been converted into antimicrobial as it has been broadened. We have seen that, right? We have a lot of resistant bacteria, resistant mycological fungi, virus, parasites. We have everything on our side. So this thing we have again it falls on 18th to 24th of November, in which how to handle an antibiotic and antibiotic care and everything will be concentrated on this part, and it has a worldwide attraction on this particular area. So what can be done actually? We have a lot of this probiotics. Everyone will be knowing what is probiotic, and it is gut intestine bacteriums, which is very helpful for our digestion, and also it produces some I would say it is a probiotic properties, which generates vitamin B and K, which requires to maintain the integrity of the gut epithelium. So rumen animals like cow, which has rumen, it has a lot of microbes in the gut, and this has been into research actually, and we have got a lot of great innovation in this particular area, and the nutraceutical companies all over the world, working on this particular area, and they have a lot of outcomes in this particular area. So like cockroaches, termites, and many other insects, and these have a GIT microbiome for their nutrition itself. So this is a competitive exclusion and colonization resistance prevents pathobionts from dominating the gut ecosystem. Actually, it is a much needed one. The antibiotics what we have for common infections like stomachache or diarrhea, these antibiotics also spoils these kind of probiotic bacteria, which is very useful in our body. The antibiotics which we intake for common infections, this will spoil the normal microbiota. That's again a serious threat for the use of antimicrobials in our body. So the microbiome keeps the GIT in a state of controlled inflammation, and it improves the host immune system in the state of readiness. It will have all the components in it, like it produces some useful probiotics things which acts against the common infections, which can be cured without taking any antibiotics. So the prebiotics again, prebiotics is nothing but it control the bad bacteria and nourishes good bacteria. It's a simple way. We have a lot of probiotics, as we have mentioned here, like inulin, which is found in guava fruit, and other things, which has a prebiotic property which enhances the growth of useful bacteria. So again, we have nutrients fermented by good bacteria such as bifidobacteria and lactobacillus. We have done a lot of research, and even some yogurt companies are using combination of 6 or 7 yeast formulations for this probiotic, and they are found to be very effective. So actually, we in our lab, we are working on three different criteria actually. We are working on, our PG students are working on ozone technology. The ozone, we all know that O3 is a very harmful one, and at low concentrations, this ozone has a capacity to induce the growth of microorganisms, and it alters some constituents in its production. Whether for example, we worked in a bioluminescent organisms. As you all know, bioluminescent organisms, it produces its own light. It doesn't. There is a two kind of bacteria. One is bioluminescent, and another one is light. It will observe the light and it transmits the light. But this bioluminescent bacteria can produce its own light using luciferase enzyme. So we use this particular criteria. This particular criteria for indicators, bio indicators for pollutants. So we are on a research on this particular thing. So the microorganisms, these have a tendency of quorum sensing. Microorganisms has a way of communication. It communicates using the quorum sensing, and it forms it emits light actually. So what happens here is the heavy metal when it reaches gets in touch with microorganisms, they lose its integrity and the light diminishes. So this can be we are working on some bio indicators for heavy metals, and also for the presence of antibiotics, harsh chemicals, either in water content or any kind of thing. So this will act in different intensity. The light intensity of the microorganisms produced will have a different intensity when they are exposed to different kind of heavy metals and also antibiotics. So we are working on that particular area, and this particular ozone has a tendency to increase the seed germination efficiency. As we have worked on that one. We found that it profusely 100% of seeds got germinated using ozone, whether in normal condition only 60% of seeds got germinated. So the ozone has also tendency to clear the bacterial content, which can be used as a sterilant in hospitals or operation theaters. So for detaining bacteria, ozone is used in higher concentration. For some useful transformation, we can use it in a lower concentration, and we have got a lot of nice results in this ozone. So the usage of antimicrobial agents can be reduced by using these kind of technologies. And again, this probiotic and prebiotic, we have exposed the ozone thing into this probiotic, and again we got a nice results actually. We have got the constituents which we have obtained from the probiotic microorganisms has been enhanced by the use of by exposure of organisms to ozone at different concentration, and we have got extraordinary results in this particular area. And I thank Veridian for this wonderful opportunity to interact with all you people. And if you have any clarification, you can ask me.
Thank you, sir. Thank you for your nice presentation.
Thank you, ma'am.
Participant, you can ask your questions. Sir, Nandini asked one question. That is, do probiotic have any role against drug-resistant infection?
Drug-resistant infections, actually, probiotics can be used as a drug. Probiotic can be used as a drug, and it has might be there is a lot of research going on this particular area, because this methicillin resistant Staph aureus, some kind of probiotics has already been working for this particular MRSA. They have already a lot of research has been done done related to probiotics, and they have got a lot of compromising results in this particular area.
Okay, sir. Thank you, sir. Any questions?
Someone has asked, how will you correlate the ozone and probiotic bacteria? So probiotic organisms, I'll answer this question. Vinodini Arumugam has asked the question here. in the chat box actually. So the correlation is it's a biotechnology actually. Normally, an organism has a tendency to produce probiotics in a normal condition, but this ozone O3 has a tendency to either it will improve the production of a probiotic constituents which is present already in its body, or it may reduce the content. So either way it may happen. So we have to standardize the exact amount of ozone to be introduced into the organism, so that it may produce a higher concentration of probiotic. Might be we have got a lot of new components when we introduce this particular probiotic organisms to ozone. It produces some different constituents, different combination of compounds other than probiotics which they normally produce. So it might be due to some mutation, or we don't know. We are working on its molecular level. We doesn't got into this molecular level of work, but we have to see whether there is any change of protein or something which help them to produce some other compounds other than the normal productants.
Yeah, okay, sir. Thank you.
Again, Ambika Hirakar, she asked, why is it probiotics do not show expected efficiency in some individuals? As we said, everyone has a different, it is based on our DNA, we might be exposed to a lot of antibiotics already, so that the components which the probiotics produce might not work with them. It is we all know what is precise medicine. Again, it is a new technology which has already been introduced in UK and other foreign countries, that every drug will act differently in each individual's DNA, act differently on it's a precision medicine. We have to work a lot on this particular area, because it is an expensive process. We have to read all our DNA whether this particular drug will work with. And again, oncology. In oncology, already we got the breakthrough in India. We are sending the samples to Bangalore. Actually, Bangalore is doing this thing. The drug and whether this particular human being will work with the particular chemotherapy. They are doing it as a precision medicine. Already it has been working out for oncology. Cancer, they are working on it in India. But these kind of small drugs, it is very expensive actually to work like this. It will be work, but depending upon the individual person, it differs actually. Probiotics, for some people it won't work, because already they'll be exposed to a lot of drugs. So their body might not respond for this particular drug. Might be a reason. It is a hypothesis again. It's not a researched one, but it's a hypothesis.
Any questions from participant side?
Nandini Samuel asked, do probiotics have any role against drug-resistant infection? Is there any research done on this? Actually, Nandini Samuel is my student. Actually, she did her MSc. She's currently registered for MSc in our department. Nandini Samuel will work on this one. Start collecting some references and we'll work on this one. And it has showed a lot of efficiency against microorganisms, and we'll combine this ozone and particular probiotics, and we'll work on this one. We'll get into touch with this. Thank you. Thank you, ma'am. There is no other questions, it seems. Thank you.
This is a time for vote of thanks. It is such an honor for me to get the opportunity to thank you all. On behalf of Veridian Microlab, I extend my gratitude to our today's chief guest, Mr. Karthik Kumar, to take out time from his busy schedule to grace the event. Thank you for joining with us on this special day. I also thank him for the excellent speech he delivered today. Thank you, sir.
Thank you. Thank you.
I extend a warm welcome to the people who all are gathering here. I must thank our team members for working hard for the first few days to make this webinar successful. Thank you everyone once again for making it a great successful. Thank you all.